To start, we've been doing the land acknowledgement. Does anyone want to start with the land acknowledgement? Maybe if you guys are familiar with what land you're on and sharing where you guys are, where you guys are connecting to the internet from, I suppose. Anyone want to do the land acknowledgement for today? Don't be shy, guys. We got to get to know each other.
Yuliangiano on Fernandeño Tatavian land.
Okay, Yoli, you're on Fernandeño Tatavian land. So are you near Theodore Payne?
Yeah, I am in North Hollywood now. My garden's in Pacoima.
Got it. Okay, cool. Thank you for sharing. Anyone else want to share where they're, what lands they're on?
I believe I'm on Yokit's land. I can't remember. It's like in the San Joaquin Valley. So like the Tejon Native. I'm not sure. I know that it's Yokit's is like one of the main tribes that were here.
Okay, cool. Yeah, you're up in Bakersfield, right?
Yeah, in the Kern
Okay.
River Valley.
Okay, yeah, I'm not familiar with the native tribes around there, so I believe you, whatever you say.
I'm gonna look into it more because now I feel like a bad human for not.
No, you're not a bad human. You're trying. That's great.
To be a more informed human.
Yes, that website, that native land website is super helpful. At least the starting point. Let's see. Anyone else want to share? If not, always welcome to share. You can share in the chat too if you guys are feeling shy. We can start with just homework review. So let me see where, I guess I have a slide for that, I believe. Gosh. Yes. So anyone, okay, so we were mature, you observed native plants. A lot of you guys sent those in to me. I mean, it's pretty self-explanatory, but anything you guys maybe wanted to share that you came across that was surprising, discrepancies between resources, or even if you like learned maybe a maintenance thing that you didn't know, or I mean, even if you, or something I saw come up in a couple people's homeworks was like sun shade. It wasn't, we didn't specifically ask for it here, but potentially like, did you notice if your plant was in the right kind of sun requirements based off of the resources? Anyone want to share?
Yeah, I could. This is David.
Okay.
I just got mine in about 2 minutes ago, but I had a Sambucus, and then when I looked it up, it was out in the open sun, and it probably was planted at a 1 or 5 gallon a few years ago, and it was probably 7-8 feet tall, and so it said it really likes the sun, but if it is in shade, it kind of does okay, but it doesn't do as well. So I think that was something that I kind of learned just by doing the research about the plant.
Yeah, a lot of it comes from the vegetable world, but anything that's got fruit on it tends to like quite a bit of sun, because that fruit, the sun basically converts into sugar on the fruit. So yeah, it's not always the case with native plants, but elderberry definitely gets quite a bit of like that fruit load on it. So definitely get a bigger fruit load if you have the full sun. What about, did you like any notes on pruning that you noticed, David, for the Sambucus?
It didn't really look like it was pruned. It was in a city park.
Okay.
And I didn't really notice the pruning. I didn't really look that closely, but I'm sorry, I'm not.
No, don't worry about it. Just ask it.
That's why we're doing this.
Right, exactly. I think, and just so you guys like, the whole point, I think I've mentioned this before, but it's just so that you guys get familiar with the resources, not so much that like you're experts today, right? It's like, it's a lifetime thing, right? Just knowing that you know where the resources are, and that, like, for example, David, the Calscape has like a little blurb, usually like a little pruning shear for pruning tips or something. So if you did want to look it up, you could just, Calscape has that. Las Politas typically has quite a bit of information on, maintenance stuff.
I
on
actually
it.
did look that up, but I didn't see it in the CalScape. I didn't find it that strong on the maintenance things. And so I'm at my work and I have some books at home and I normally would have checked on those too, but
Yeah.
Anyway.
Yeah, you still got time. Yeah, I kind of like to look at books more too. I feel like that's like the like, I don't know. I just still really like having books. But anyone else want to share their homework? Maybe I'm trying to think of just anything interesting or even not interesting, even if it was just something simple.
Hi,
Yeah, who's talking?
Lola.
Lola. Okay, go for it.
So I work at a farm in Pomona where I
Uh-huh.
watch over some beehives. And
Cool.
every time I walk into the farm, it's a half acre, so it's not too large, but it's very beautiful. There's some Encelia. Is that how you pronounce
Yes, and or Celia and Celia. I mean, it's a
Ence-
dead language.
Encelia?
So, yeah.
Encelia flowers. Um, and they're just always buzzing with native bees and different types of pollinators. And they, so with maintenance, I believe they just like put the seeds down in early spring and the flowers have been blooming like ever since, and they still are blooming. And they do like prune it back every now and then just because it's like in a walkway.
Mhm.
But it's like so large. It's like I'm about like 5'4", and
Mhm.
it's like taller than I am.
Oh,
But then
wow.
there's like some bushes to the other side of the walkway where like they are shorter.
Mhm.
So I think maybe it's just because they've let those grow longer and kind of have been
Yes.
pruning them to like go along the fence side.
Yeah.
And then when I was looking at the flashcard and then Las Felidas, I saw that it's kind of like ranges from 3 to 4 feet. So I guess it might just depend like how much water they get or the area that they have.
Right. And sometimes too, it can be like if they're buttressed on like, if there's a fence on one side, it kind of
Yeah.
goes more vertical if you notice that.
Yeah, that does make sense to the side where there is a fence. And then what else was I gonna say? No other questions are on here. Oh, on the website Las Politas, it was saying how it likes to grow with different types of plants. And
Oh, right. They have the companion plants part, right? Good
yeah,
point.
and at first I didn't really notice the other flowers or other native plants. But then when I looked at it again with the questions, I started to see like little differences here and there. So I'm not sure if
Do you mean
those
on
were
the same plant or like a different, you started to
kind of
notice
like
other
growing
plants?
around,
Got it. Okay.
like weaving in between.
Got it. Okay. So it's like a pretty
Yeah.
densely, it sounds like a pretty densely kind of vegetated area. So it's not just
Mhm.
like one plant and then the next one, it's like a bunch there.
Yeah.
Got it. Okay, cool. Yeah, thank you for bringing that up. That's a really good reminder that CalScape and also Las Politas, if on their kind of, they have the plant community area, they talk about other companion plants. So plants that you typically find with them. And I'm glad you brought that up because I totally forgot about that kind of feature. And that's really helpful for garden planning, because like in your case, you actually saw that they were growing together. But if you were maybe wanting to put, like maybe somebody asks you to create a pollinator garden and you'll be like, oh shit, I'm definitely gonna use Encelia because you know from experience that there's tons of bees. But then you can also use those resources that are like the other companion plants with that so that, to kind of like recreate a plant community. So thank you for bringing that up. But also, it's cool that you were able to like start to actually identify other plants just based off of trying to identify one or notice one. Which is kind of the rabbit hole, I suppose, of just identifying plants in general.
Yeah, that website Las Politas is definitely has a plethora of
Yeah.
so much information.
Yeah, for sure. So much information on, I mean, both of them. And I feel like, if you just want to go down a rabbit hole of plants, CalScape, Las Politas, both are like endless tunnels of information. But I feel like there was going to be one other thing I was going to say about the Encelia. Oh, which I think I mentioned in the plant ID class. But Encelia has that kind of, for any of you guys aren't familiar, Encelia kind of looks like a sunflower flower. It looks like, a typical daisy or sunflower, the yellow one. It's definitely in your flashcards if you want to take a look. But anything that's like that that's like that flower, that's the Asteraceae family, which is kind of like the sunflower family. And there's tons of different species in that family. And all of them, like basically pollinators love that whole family. So that aster shaped flower, or that daisy shape or sunflower type of flower is typically really good for pollinators. So anytime you see it, like in the case of Lola, where this Encelia, she says there's tons of native bees buzzing around it, but also something like Erigeron glaucus has a similar shaped flower, though a very different looking plant, is going to have a lot of pollinators because of that type of flower. It's basically a bunch of little flowers in one. So pollinators love it. Also, you mentioned the, what's it called? Oh, you can deadhead those. So you were saying that some of them get kind of cut back all the way. You can deadhead them back and they'll continue to rebloom. And also you can actually cut it back, some of the older ones every couple of years, and get like lots of new growth. But it does vary with the shape. Some are a little more like leggy and sprawly, like you described, and others can be more of like a bush, like a very kind of typical bush shape. So it's cool that you had multiple to compare.
Yeah, it was incredible because they like cut them back. They cut them pretty far back because it's just a pathway. But then like the next 2 weeks, like it was like they were back. So definitely keeping those in mind.
Yes, definitely a really generous grower, a generous flower. And that's hence why it's on your guys's easy native plants for SoCal, because it just kind of keeps blooming, and you can hack it back pretty hard and it still comes back. So like totally lived experience and example of an easy native plant. Anyone else want to share a homework discovery, interesting case? Don't make me pick, guys.
Hey,
Go for it. I think, okay.
So both of my examples were of coastal sage scrub plants that
Okay.
like had kind of weird shapes to them. And I think it's something that I see here and there where if you put those plants that are like, like buckwheats or salvia in very exposed, or plants that want to be in very like exposed sunny areas, and you plant them in kind of more shady areas, they get kind of like weird shapes, I think.
Yeah.
So yeah, that's one thing I think I've been observing.
Great point. Yeah. So kind of weird shapes, or a lot of times if they want more light, like if it's something that's would like a little more lightness and shade, they actually get very leggy or like kind of longer, because they're actually stretching to kind of try to find that sun. So which does create like a weird shape. But great observation, because yes, it's like sometimes you can actually use that to your advantage. Like say you want something that's a little more sprawly, or sometimes it can stunt the growth of something, and maybe you want a little more stunted of a growth on something, and you can actually kind of like put it in the shade if it prefers a little more sun to stunt it. I mean, you're messing with its ideal conditions, but it's something you can actually use, you know what I mean, for like to your advantage if you want to.
Yeah, like observing that kind of behavior and then thinking about like what the plant wants to do.
Yeah, that's like super key. I'm really glad also, I totally forgot to put this in the kind of the slide here, but it was definitely something I wanted to mention and almost wanted to put as one of the questions, but I'm glad you just mentioned it, which is what plant community does your plant like native to? And I'm glad you brought that up, because I totally forgot. But that's a great kind of exercise to do, especially when you're looking at plants in the horticultural setting, which maybe they're not in their natural setting, but thinking like, where does this plant want to be, or what kind of community would it normally come from? And you said yours is coastal sage scrub, and did you also say chaparral, like a mix
Yeah, well, I mean, I guess it's not, like you said in the last class, there's kind of a gray area, right? But so it was like I see it a lot with buckwheats, but the two photos that I took were of a baccharis and a crazy looking sagebrush.
Yeah, yeah, both of those you could see in both communities for sure. But yeah, I'm so glad this is why we do review, guys, because you guys come up with the questions I meant to ask. But yes, the community, like thinking about the plant community, I like how you're thinking about it, which is like like why does this got a different shape to it? Maybe it's because of the strange light conditions that it's in, and also like what kind of plant community it's coming from is super helpful, because yeah, maybe it's in the wrong one, and maybe that's what's contributing to its strange growth habit or like failure in a plan or anything like that. So like really important note when you're like looking up and researching about a plant, maybe not just looking on Calscape, but actually Calscape does tell you that. But anyway, yes. Anything else? Anything else you wanted to share, William?
No, and it's true. You're right. Definitely the baccharis was it was like moundy and leggy on the bottom part. And
it was,
yeah, I mean,
yeah, sorry.
No, and the gardens are interesting because the gardens, like our gardens, are never quite like the natural habitats that are adjacent to them, because we have like big trees and structures and stuff that kind of like influence well, definitely how sunlight works, but a lot of different factors like that. Yeah.
And a lot more reflected heat usually in an urban landscape.
Yeah.
So like a lot of times you'll have these huge trees, but you also have like, asphalt that's just like reflecting a lot of heat, and obviously a lot of buildings reflecting heat and even light. So maybe something's not in direct light, but it's got like a white wall right next to it, and it actually gets, it's interesting because our urban landscape is so different from the native or the wild landscape. So yeah, you're kind of thinking about all these other factors and considering those in the urban landscape, or even just any kind of altered landscape, human altered landscape.
Yes, totally.
Yeah, cool. Thank you for sharing. Let's see. Let's move into the lecture, since we got only so much time. But thank you guys for sharing. I really appreciate it. I love not having to do the okay, I'm gonna call your names. So thank you guys for sharing. Today we're gonna talk about soils. I think this is my favorite lecture. I love talking about soil. The objectives for today are talking about, we're gonna try, hopefully you guys will be able to identify soil textures by the end, and the soil textures relationship to infiltration. And we'll talk about some soil-based problems that you see with native plants, and then talking a little bit about soil management with mulch and potentially amendments. Okay, trying to have all the chats and everything organized so I can see the slides and also talk. So what is soil? Soil basically is composed of these 4 components, and so we got this little generic pie chart here, but most of it, like about 45% of it, is mineral matter, which is minerals from broken down rock. And that's just like most of your soil. When we talk about like what exactly is soil. And then that little gray sliver, approximately, somewhere around 5% is the soil organic matter, which is the living and decaying organic matter in the soil. This is like the living, this is like all age, dead and alive stuff, like little twigs and leaf litter to breaking down humus to, or broken down humus to like earthworms to bacteria to microorganisms. It's like all the living stuff and all the dying and dead stuff, so it's that's all within that tiny little sliver. That's the considered the organic matter, or soil organic matter is what it's also referred to as. And then the other 2 components would be air and water. So just that's what soil is. That's what it's made up of. Essentially on the left-hand side here of the pie chart, these are the solids, like this is physical material you can hold in your hand, And then on the right-hand side, we kind of refer to this as occupying the pore space. So water and air occupy the space between the physical solids matter. So it's a bunch of minerals and organic matter, or not very much organic matter usually, and then a bunch of water and air occupying the space between. So properly managing for all four of those components is going to lead to a healthy landscape. And this goes for all landscapes. This isn't just for native plants. This is just, you're always managing for all four of these things. I think, was there anything else I want to say? No. Okay, so soil provides three basic functions for plant growth. There's a lot of, I mean, we are simplifying. This soil lecture could be like, a whole PhD. So we're trying to simplify this, but in terms of basic plant growth functions, soil is anchoring the plants. It's like the medium that actually anchors the roots, right? And it's the home for microbial and fungal activity. And then lastly, it facilitates the moisture and nutrient movement. It's the medium that like allows that that process to happen. We're really, the last two, the microbial and fungal activity and facilitating moisture, are very connected. And but we are mostly going to talk about the third function and how moisture is important for moving nutrients around. At least today, that's what we're mostly going to be talking about. So really, soil captures, like when you think of soil, when it rains or you irrigate or whatever, soil is capturing and storing the water in it. And then the plants use that moisture to grow. And basically the nutrients that are existing in the soil dissolve in water and get sucked up by the plants. And so really moisture is so critical to nutrient movement and cycling for the plants. That's why a lot of times with fertilizers, like synthetic ones, if you apply them, you need to water them in, because it needs to be dissolved in water and then sucked up by the plants. So soil is really important for that facilitation of that moisture process happening. And just so I'm just trying to really make it clear that moisture is really what moves nutrients through the system. And soil is just kind of the medium that everything's in. But we're going to really talk about how water moves through different kinds of soil. And that's going to be critical to understanding and maintaining a healthy garden. Milton, you said, when we talk about soil, do we break it up into levels or classify it as a whole? I think we're going to get into this into the next slides. And if I don't, re-ask me that question, because we're going to talk about the different types. So I think we will be answering that. But let me know if I don't. Okay, so I'm trying to get rid of, there we go. Okay, so soil texture. Soil texture is this classification method that is based on the proportion of individual particles of sand, silt, and clay in the whole soil. So it's the proportions of the different mineral matter. So we're talking about this little section of the pie, just the mineral part when we talk about the soil texture really. And that's what proportion of sand, silt, and clay do we have? And that's how we identify what kind of textural class or soil, or people usually say, what kind of soil texture do you have? And usually it's by determining the different proportions. So I'm going to talk a little bit about these different particles, the sand, silt, and clay, and then we'll talk about the kind of soil textures. So you can also learn to identify your soil by feel. It's not, well, we'll get into that, but yes, it's possible. So sand, starting with sand, which is, we're starting with the largest particle and moving to the smallest. And sand particles are the largest, and they're typically very irregularly shaped. And they usually don't really hold minerals very well. So they're large and irregularly shaped. There's a lot of space between the particles, and we call that a lot of pore space. So that was what I was showing on the right side of the that pie chart, a lot of space between, because they're these big kind of strangely shaped particles. So that means water can move really quickly, drain very quickly. And also it means it's the open kind of permeable nature of it means that the roots can grow and stretch out and develop very easily, because there's so much space and it's not very difficult for it to move through. Also, just by feel, you guys probably know, if you've ever been, I don't know, been a sandbox or a beach or anything, sand is very gritty to the touch. You can feel that grittiness in your fingers. let's see. So yeah, thinking about sand as just a large irregular shaped particle is important for later. Silt is the second component, second particle that we're talking about, and it's the medium-sized one. Typically, you see this kind of material that it gets carried away with by like water runoff or flooding. It's very much found in like stream deposits, lake beds, maybe like a harbor, or like floodplains and deltas. So it's very much a material that is that gets found, that goes with runoff very easily. It's, oh, I didn't say this. It's the medium-sized particle, and it's usually very spherical in shape. It's a rounder particle, and because of that, it's to the feel, like to the touch, it's very much like flour or baby powder. It's the sediment that really gets carried. Oh, we already said this, that gets carried away by water. But silt is kind of nice in that it can hold quite a large amount of water, but also releases it pretty readily. So it's a kind of middle ground, like whereas sand drains water very quickly and doesn't really hold on to it. So generally though, like I said, it's in these kind of areas near river deltas and stuff. So if you typically won't see these really high silt soils in Southern California unless you're near one of these kind of features. Clay is the third particle, and clay usually consists of the smallest particle, and they're usually very flat-like, almost like a plate-shaped particle. So they actually kind of lay on top of each other and fit together very densely. And so you'll see there, because of that dense kind of fitting together, water doesn't have as much ability to move through it as easily like it does with these big irregular shaped particles like sand. So think of them as these flat kind of plate-like particles, and they're very small. They're much smaller than a sand particle. And to the touch, you know, you guys probably know it's a bit stickier, you know, when it's wet, it's kind of gets sticky. And clay typically, I mean, this is this is what you know from playing with it or anything, but clay can hold onto water very well. And that also doesn't release it very easily. You know, once it absorbs it, it doesn't let go that easily. So that's why with clay, it kind of stays wet for a while, or it can have that sticky kind of feeling for a while, because it can hold on to water because it's so densely packed. So it's like the water kind of gets in between those little spaces and actually kind of stays there. So what else did I want to say about that? Oh, well, it's obvious, but this is like it swells and contracts with the addition and removal of water. So like this picture on the left is when it contracts, is when there's no water, and it actually kind of shrinks. Okay, and then this is just a kind of image of the relative size of the particles. It's not good for the shape. They are not these shapes except for maybe the silt, but it's good for seeing the relative size. So the yellow, big yellow one is the sand, and it says it's like from 0.05 millimeters big. So this is something you can see with the naked eye. And silt is like 0.05 to 0.002 millimeters large. So this is something you need like a microscope to see. And then clay is even smaller, and again, not round, but a flat and more rectangular shaped, is less than 0.002 millimeters. So this is something you need like an electron microscope to see it with. In fact, in your student handout, for today's handout for this class, there is a picture of like an electron microscope picture of clay, and you can see it's like a bunch of sheets of paper kind of stuck together. But again, you need something like an electron microscope to see this. What did I want to, oh, so yeah, so the particle size and shape, so not just the size, but the shape also is going to determine how the soil behaves and how water moves through the soil. And that's because like the water, like I was saying, can get stuck kind of between the tighter, densely packed clay, and it's a lot looser and can move more freely in the larger pore space of the sand. Okay, so the soil texture triangle, this is a triangle that uses like the relative percentages of sand, silt, and clay to classify soils into different textural classes. This is if you want to be really more precise. You know, typically people just say, oh, I have a sandier soil, and that's usually enough for just kind of, you know, working situations. But if you want to be really specific, you can use a textural triangle. You typically would need to do either like a jar settling test, which you can Google, and it's basically like you did take a little soil sample, put it in a straight-sided jar with some water and a little bit of dish soap, and you shake it up really good, and then they settle out by size. So the sand particles settle out first in like the first couple minutes, and then the silt is in the next, I think, like half hour or something, or hour, and then the clay is like over time, over the next few hours and even day. And so you'll be able to see the separations in the soil, and actually then you can actually get a measurement if you wanted, or you can send it to like a lab or whatever and get the particle size breakdown if you wanted. But that is a way to do it. I try to have those in the class, but either way, you can Google it. It's very easy to do. But if you were to do that, you could actually figure out based on the percentages, what type of textural class you have exactly. I have a lot of notes on this slide, so I want to make sure I don't miss anything. But typically you see, typically you hear people talk about loam, like, oh, it's a really nice loamy soil or whatever. That is really more for agricultural settings or vegetable gardening or anything that needs a lot of nutrients, which is not the case with natives. But loamy soils typically, or when people are like, oh, that's a great loamy soil, it makes sense for these high nutrient needing plants like agricultural stuff, because obviously we're eating it, so it needs a lot of nutrients. So loamy soils are typically for that. So when you hear that, don't be afraid if you don't have a loamy soil, because with our native plants, we're not restricted to just loamy soils. In fact, as we talked about in that last lecture, California has such a diverse has so many diverse plant communities, and also has a lot of diverse soils. We have a lot of sandy and clayey areas that obviously grow plants. So there's a native plant that grows for kind of every soil type. So we typically kind of have more clay and sandier stuff in Southern California, but there isn't like a perfect soil. It really goes back to that picking the right plant for your type of soil. So, and also our native plants are adapted to these lower nutrient soils. Like the loamy ones hold on to a lot of nutrients and typically are a little bit more high in nutrients. And the clay, well, just a pure clay or a sandier one, less so. But that's okay, because native plants are adapted to these low nitrogen soils. So we don't need a perfect loam for native plant success, is kind of the point. I think David says, is there a preferred soil texture type for native? Yeah, there isn't one, is what I'm trying to say. Sandy loams are nice, and sand is nice for drainage, but there isn't a perfect one. And there's definitely lots of plants that work well in clays. Let's see. Oh, one thing, you can't change the texture of your soil. Don't try to like get enough bucket or like truckloads. It's just a bad idea. And it's not possible. You just really can't add enough of like silt or anything like that to actually do it, and to mix it. It would be really hard. One thing I wanted to say is the clay, one kind of point here, you can see the clay kind of part is very large, which just showcases that clay is a really dominant characteristic in a soil. So that means like if you have a 60% clay, you're up in this range. The numbers are oriented with the line. So 60% clay here, or if you have a 90% clay, it's all going to behave the same way. It's all basically a clay soil. So 90 or 60% clay is the same as clay. You know, they're going to behave the same way. And that's not the case with sand. You go down here to sand and we have a 60% sand. That could be any one of these three. And then a 90% sand, and that would be this little triangle that's considered a sand. So yeah, it's not what the point is that, oh, excuse me, the clay soil is just a very dominant characteristic, and the more clay you have, the more it will tell you how to treat your soil, and like how you want to be a little bit more careful about compaction. The more clay you have, it's a lot harder to compact sand, though it's possible. But clay, it's a lot easier to kind of destroy the soil structure. So it's just working with what you have, and you can totally have success. And it really is that reminder that planting the right plant for the right place. It's very rare to have 100% of any one of these soil types. So it's rare to have 100% sand or 100% clay, and especially 100% silt. It's very rare to have that kind of soil, though you might find yourself in this category where it's equivalent to 100% clay. It's very rare when you do the actual settling test or you take it to a lab that it's actually 100% this type of soil. So I just want to make that clear, because one of the things on your handout is a little misleading or confusing. Let's see, what else did I want to say? Oh, I actually have a poll for this, I think. Wait, did I want to say anything else? Yes, no, I didn't. So here, I'm going to do a little poll. So say we have the results from a settling jar test that indicate a soil sample with 50% clay, 30% silt, and 20% sand. Using this texture triangle, which soil texture would you classify it as? The point isn't that you guys like get really good at this, but I have a follow-up question. So again, you have this, the numbers orient with the line. So here is clay, they go across horizontally. Silt would be at this 30% range. So they actually orient like this. You can see the numbers go like that. And then sand is over here going that way. So go ahead and add your, give me your, your best guess or your best answer. I know it's kind of hard to follow along with your little fingers on the screen, but trying to identify what kind of soil would be a 50% clay, 30% silt, 20% sand using this texture triangle here. So here again, clay on this side. Let's see, we've got 15 of 25 of you have answered. Keep going. I want at least 80% participation, guys. Or throw it in the chat if you have an answer. You can throw it in the chat. Oh, are there nitrogen fixing native plants? I just saw that in the chat. Amelia, there are nitrogen fixing native plants. One on the top of my head is, off the top of my head, is Cercocarpus beryloides, the mountain mahogany. I love that one. So that's one that's always stuck in my head because I always am like, it's also nitrogen fixing. So that's kind of a cool one. But there are several that do. I think Acmespon glaber, which is deerweed, also is a nitrogen fixing. You can see it kind of has a pea-shaped flower. A lot of the pea family are nitrogen fixing. So there are, yeah, thank you. Netta said lupinus too. So lupine also definitely has, yeah, there's several of them. Okay, it looks like we have 80%, good. I'm seeing some, let's see, I'm gonna share the results, I think. I hope you guys can see this. So it looks like majority almost say clay, and then we had some all over. I'll just go with it on my, go through it with my mouse here. But like I said, so 50% clay, I'm here. And then I said 30% silt. So that's all the way to this line here. This is silt. And then that would go with this 20% sand. So I'd be in this range. So I would be definitely a clay soil. That would be considered a clay soil, not the other ones. So that being said, though, even though we have a little bit of, oh my God, I have a crazy mouse. Though we have a little bit of sand and silt, I think someone's mic's on. If you guys can mute yourself just for a little bit so that it's not so distracting. But anyway, even though we have sand and silt represented even in 20 and 30% in this soil, it's still considered a clay. So that was kind of the point I wanted to make. And my follow-up question would be, if I were like a new gardener, I'd have no experience in gardening, would you recommend that I plant, say, like a Dudleya, or a Dudleya maybe in this type of soil? Like I just did this soil settling test. What do you guys like? Why or why not would you recommend me to plant something like a Dudleya in a soil like this? Feel free to write it in the chat or unmute yourself. I know I just asked you guys to mute yourself, but feel free to tell me why or why not.
Well, that's found in the desert, and usually it's sandy in the desert, so I would say no. Yeah, that's a great rationale. I kind of agree. Yeah, David, yeah, you said the sand for good drainage. Exactly. And if you aren't familiar with Dudleyas, you can look it up in your little flashcards. But yeah, they typically like a lot of drainage. So if it's a new gardener, I would be like, I don't want to set them up for failure. So maybe not set it. It's not impossible to plant stuff in clay, but it just means that something that really wants good drainage, maybe avoid planting it there. So yeah, I just wanted to kind of have that little example. If you can't use the texture triangle, don't worry about it, guys. There's no like, there's no main, like, I don't know, test where you have to know how to use that. But I just wanted to kind of use it for the exercise. So
let's see, was there anything else I want to say about that texture triangle? No. Okay, so back when this class was supposed to be in person, we were going to have this kind of soil texture by feel test, but it's not in person anymore. So it looks and sounds more complicated when you have to describe it and write it all out. This is actually very simple to do in, I'll get to you in a second, Milton. So it's very simple to do in real life, but I'm going to walk you, we're going to basically show a video of this process, and then but you should know how to do it because it will be in your homework this week. Milton, what was your question?
So on the triangle, it showed like a huge cross section of clay. Does it matter?
Oops.
So kind of mainly talking about Rio de los Andes kind of state park, because so that the soil there is definitely clay, but it has so many kind of rocks and in it. Does it matter in terms of like the soil that there are so many like stones and rocks in there, or is it just?
Oh, I see. No, or do you mean like for identifying what kind it is?
Or like in terms of like how you plant, or does that play any consideration of how like?
Well, I would say, if I'm getting your question right, like the bigger boulders and bigger rocks are, yeah, they're gonna well, first of all, the bigger ones on top are great for like kind of a nurse rock. The plants can kind of like hide behind them when they're young, and it protects them and kind of holds moisture under a bigger rock. In terms of I think what I'm thinking of when you're explaining it is like sometimes it's hard to find soil to plant into when you have a lot of rocks and kind of arroyo situations and just like clay and typically silt even on top. It's almost hard to plant into. Is that what you're referring to?
Yeah. So this one, like I kind of joke and say it's like, what is that? A conglomerate rock, or just like just. I would say like 25% of the clay in there just has like stones on it.
Yeah. I mean, I think if it's if it's 100% clay situation, or it's like in this clay category, I would almost suggest doing the settling test in that situation to be really sure, because you might be in the kind of silty clay loam situation, especially if you're like an arroyo type situation. And those are actually really good at absorbing and releasing water, whereas the clay, it really sticks a lot more.
This one, like, yeah.
This one's very sticky.
No, in terms of like we dumped a bucket of water in there and it just kind of just stayed. Didn't.
Yeah, it doesn't drain.
Yeah. Just.
Yeah. So I mean, it's hard to say, but I would really suggest anytime you have clay soils, even if there's big rocks in it or gravelly things, because those rocks and gravel aren't necessarily adding to the texture. They're like too big, unless there's some sand in there. But otherwise, those bigger rocks, that's not going to be part of your soil sample. And in that case, I would be definitely planting clay appropriate plants, which there's a list actually for your handout this week, but we'll get to it too in a slide.
Oh, thank you.
Yeah, I think we can talk about it more too at the break. So anyway, going back to this soil texture by feel test, it's called, well, don't confuse it. It's all one test. You actually squeeze it in a ball and you do a ribbon, but people call it the ribbon test or the ball test, whatever. It's all that you have to kind of do all of it. Like I said, more complicated looking when it's all written out. But I will show a video. But what I want to just remind you guys of is this is the printed version, but there's a flow chart of this process that is so much easier than what's written here on the slide. Just use the flow chart. It will literally start off with like, put 25 grams of soil in your hand, wet it. Is it, can you form a ball? No, go this way, and so the flow chart I think is the easiest way. It's in your handout. The e-version also has it. Look for the flow chart in this week's class. I think it actually might be part of your outline for this week's class. But one thing I want to warn you against, I actually tried to get rid of this, but there's this image here. It's like a little 3 hands figure that I think just is misleading. It has some interesting points about sand, silt, and clay, but it's really misleading in that it makes it seem as though if your soil sample doesn't form a ribbon, it's a silt, which is not the case. It's usually probably a loam. But I just want to warn you against going for just looking at that little freehand image. Just a big warning, it's not very precise. And I think this was an image that was used for, you know, like a kind of a less precise lesson plan potentially. And we want to be a little more specific than that. So I would say just avoid that one and use the flow chart. But the reason I'm harping on about this is you want to be able to do this because of the homework. Basically, you're taking a handful of soil, add some water, break up any of the you know, clumps, get rid of any rocks or anything. Knead the soil until it's like kind of like cookie dough. You want it to be kind of moist, kind of you know, not too wet. And then try to squeeze the soil into a ball. And that ball, when you open your hand, if it keeps the shape you made, like keeps the ball shape, then that's called a cast. And if the cast doesn't fall apart, that's part of your flow chart. And if the cast does fall apart immediately, it's usually a sand texture. Just immediately like, okay, you're in the sand texture. You don't even have to go on to the ribbon test part because it didn't form a ball. And if it remains in the cast shape and breaks apart a little bit, it's like a loamy sand. And if it just, you know, there's these little categorizations, loamy sand or sandy loam, they're actually different, but for working situations, they're not too different. But this is just for the exercise of being able to use, to identify what kind of soil texture you have. And then once you get past that, say something is still holds its shape, the ball, you can squeeze like a thin strip of soil from the cast between your thumb and forefinger. It kind of, I don't know if you guys can see me, but you're like kind of pushing it through your thumb and forefinger like this. And if it forms a ribbon of like more than an inch, it's usually like a clay loam. If it's a really long one, it's just a clay. If it's shorter than that, I believe it's a like just a loam. So yeah, I'm going to show the video, but again, you have this in a flow chart, and I just want you to be able, I want you guys to know all the different ways to do soil tests so that you can kind of cross-reference them, because these are all kind of like DIY ways to identify what kind of soil texture you have. So here's a video. This is an Australian, so there's some fun accents coming.
Soil texture is basically the composition of the soil in relation to sand, silt and clay, with sand being the coarsest fraction and clay being the finest. Now, it's important to understand your soil texture as it has some major implications on soil management. It's important because it influences water holding capacity, water infiltration, nutrient retention and erodibility of the soil. Soil texturing is an easy thing to do. There are two main ways that you can determine your soil texture. The first is very simple. It's a soil test and sent away to the lab for a particle size analysis. The second, also quite easy, is to do it yourself in the field. It uses your hands and some soil, a very easy thing to do. Firstly, we take our soil that we've sampled, you take it in your hands and you give it a nice little push together with your fingers just to break up the smaller pieces. Anything that's more than about 2 millimeters in size, rocks or coarse fractions like that, should be removed before you start texturing your soil. So we break it up so we've got a nice palmful of soil and we can begin our soil texturing process. If the soil's dry, then I would suggest adding just a little bit of moisture just to help it all come together. And then using your hands, push all the soil together. Work it between your hands until it forms a nice moist ball. You don't want it too wet, but you need it to come together nicely. We may need to work it for 1 to 2 minutes, and we really want to feel in this 1 to 2 minutes what's present in our soil. So if you've got coarse sand, you can really feel the coarse sand within the soil. And while you're spending the 1 to 2 minutes, why don't you think about what you can feel? I often close my eyes to help the process. For example, if you've got sand, especially coarse sand, you can really see it and feel it in the soil. If it's a fine sand, it might be slightly more difficult, but holding it to your ear, you can often hear the fine sand in there grinding together. Now, a clay is very much like plasticine. It forms a nice ball that holds together, and it's often quite sticky. And if you've got a lot of silt in your soil, like this one appears to have, it stains your hands quite a lot. It feels silky to the hands, so it's important to take that time to really feel what's in your soil. So when you've worked it together for a while, the next process is to form a ribbon. So we push it between our forefinger and our thumb. And in pushing that, we're creating what we call a ribbon. And we do this a few times so that we get an average across the ball. And I'll probably get about 3 out of this one. We push that through, and it looks like in the surface soil, we're getting little ribbons of about 1 to 2, maybe 3 centimetres maximum. Then you can use a ribboning chart to assess what type of soil type you have. So you should be able to now determine what the water holding capacity is likely to be in your soil, the best plants that are suited for your soil, and any potential issues that you may have going forward in your production system.
Okay, so so that video, yeah. So again, like she was saying, use all your senses. You can, you know, touch even your ears, and that's really important for like doing the soil test by feel. You can, she, unfortunately in this one, she kind of skips the cast part, you know, where you hold it together. It's clearly not a sandy soil though, because she's able to make ribbons. That's why I would really recommend you guys go use the flow chart. The flow chart's there so that you can do the full kind of test, soil test by feel. And oh, and one reminder too, what I liked that she showed is you saw her hands were very much stained. And she mentioned that that's very typical of silts. That is the case. Clay doesn't really stain your hands as much, even though it's very sticky. And silts actually like stain to the point where like a clay might stick and stain a little bit, but then you can get it off pretty quickly. Silt is a little bit more resistant. So unless you're really seeing that staining thing, don't think that you have silt, because SoCal, we don't typically have tons of areas with in waterways and stuff like that with high silts, but it's possible. I'm not trying to say that it's not possible. Kimball, you asked, can you do the soil test in a jar with soil and powdered dishwashing detergent? Yes. Yeah, you've used this process in the past. Yeah, I mentioned that in the with the texture triangle. You can do that. That's one method. There are many methods. We're trying to kind of offer one by feel so that you don't have to have the jar and the whole thing. Something you can kind of do in the field pretty quickly. But yes, that is an option, and that is a better option for using the texture triangle, because you can actually measure out like the percentages. But in this case, this would be the texture by feel test. So for your homework, you could do that, Kimball, do that in addition and cross-reference it. Like see if you get the same results from the settling test, the jar settling test that you mentioned, and see if it matches with the flow chart test by feel test. Oh gosh,
Soil texture.
we're starting again. Okay, infiltration. So what infiltration is just the rate at which water moves through the soil. So it's very much tied to the soil texture that we just talked about. The higher the infiltration rate, the more quickly it moves through the soil, and the lower the infiltration rate, the more slowly it moves through the soil. And the soil texture very much influences this infiltration rate. And that's very much because of the pore space, which is depicted here in this kind of graphic. Basically, the larger pores between something like sand particles, we talked about them being a large particle and irregularly shaped. So you have a lot of this dark gray area, which is the pore space in between for water to like flow through. And I mean, you can almost think of it as like a ball pit, you know, like a big ball pit with a bunch of dented balls and like soccer balls and dented basketballs and some footballs thrown in there, all these different shaped things. If you poured a bunch of water over it, if there was no bottom, it would go through that pretty easily because it's just a bunch of big particles. And on the right would be something more like a clay soil. It's a little bit tighter. You can see there's a lot less there, smaller. This is not, this is actually not my favorite image, but it's not, what's it called? Appropriate size. This is not accurate to the discrepancy of size. Anyway, you can see that there's less space between. So it's a lot harder for the soil to move, the water to move through it. One big caveat I have with this image is its vertical kind of look. So I'm trying, if you guys can see my video, I'm gonna try to show what I think it looks more like with the clay particles. So the clay particles actually fit together more like a bunch of sheets of paper, like if these are a bunch of catalogs and notebooks, but if these were all clay particle pieces, you can see they're very densely packed together. And if I were to pour water on this, it would have to travel kind of sideways and then get in between the like parts in between. And so it's pretty slow. It's slower than if it was just, a bunch of like a big ball pit, like I was saying. So in this is more accurate to what what the clay soil looks like. These flat kind of plate-like particles, more rectangular. And I guess why I'm having the caveat here is because it doesn't, I think this image gives you the impression it's actually like this, like it sits vertically like books or something, and it doesn't. It sits more like a bunch of stacks of paper or a lot of plates. And if you imagine that same ball pit just filled with stacks of paper or plates or something like that, the water is going to like sit and kind of absorb and slowly trickle down the sides, but it's going to move sideways more than just vertically. So yeah, I just want to make that distinction. The clay soils have tighter pores and actually move more horizontally. And here it describes it moves more through capillary action because of that sideways movement. Whereas the sandy soils, it's really gravitational pull that's just making it go straight down. And so this is kind of a cool little graphic that shows you the depth and the water and how long it takes. So on the left and right side, it shows you how long it takes to get to this depth. And you can see like at 12 inches for sandy soil, that's possibly in 15 minutes. Whereas the clay soil, this is in the hours range to get to 12 inches. And it's like a much bigger, what am I trying to say? Like a bigger spread. And again, it's this capillary action. It's the shape of those particles. It widens out and actually moves wide before it moves deep. So that's something you really want to keep in mind when waters get saturated, when you're irrigating, but also when you're picking plants, even actually irrigating when you're placing emitters. If you're placing drip emitters on a clay soil, you can see here, you don't need to place them so tightly together. Whereas if I were placing an emitter, I might have to place them closer together. And also run times. So a sandier soil, you could run it longer and it's going to drain pretty easily. Whereas I might run it for an hour and it would still be soaking in at the top, or it'd still be saturated and sitting at the top. So these are really important concepts to understand for later actual things you're going to do in the garden. Let me see. It says, how would a person like myself do some of these exercises working from home and I don't have the access like I would if I was working? Jerry, do you have access to any kind of soil at nearby? Because if so, you could just try, maybe you don't have a garden setting, but you could just try these, all you need for a soil doing the soil by feel one is just like a handful of soil. So just dig a little bit in whatever soil you could find nearby your home if you don't have access at work right now. And yeah, just if you can find some place where, maybe you could even go to a park and do it. But yeah, you don't need a lot of soil to do the test. And even digging the hole, you could just cover it back up. Hopefully that's doable. Let's see. I think I went over this image. I love this image. It's also in your outline, I believe. Yeah, parks work great. I mean, they're public space, man. You gotta use it for your learning. Okay, what is this one? Measuring soil infiltration with a percolation test. So we had someone mention the jar settling test. Obviously, there's the test by feel with the flow chart. There's also the percolation test. This is also in your homework. So if you don't understand this, let me know. Essentially, very simple. You would go to an area that you're planting in. Jerry, if you only have access to a park, do that. But ideally, if you want to know the infiltration of a soil, you want to know the infiltration of a soil that you're actually going to plant into. So if, make sure you're actually digging the hole where the plant's going to go, not in like the compacted pathway. That's all I'm trying to say. But you're essentially going to just dig a straight-sided hole. Make sure it's straight-sided, because if it's at an angle, it would change the results a bit. You can just do it 12 inches deep by 12 inches wide, or even just do like a 1-gallon pot. That's even less, but it's straight-sided. As long as it's a straight-sided pot, that depth, fill that hole with water. And then you just let it basically drain, or infiltrate would be the word that we're using. But you want to let it drain completely and essentially check it every 30 minutes until it fully drains. And I mean, like, maybe it's got that like little wet bottom, but there's no real water present. It's not like an inch of water sitting there. Fully drains. And that is going to tell you what kind of soil infiltration, rate you have, right? So I think I have that here. Yes. Okay. So like you're gonna dig that hole, let it drain fully. And a lot of times people will be like, oh, it drained. It drained almost all the way in like 15 minutes. And then the last 2 inches took like 3 hours. Well, it has to fully drain. So if it takes 3 hours to fully drain, I don't care if it took only 15 to drain most of the way, that 3 hours is what's going to give you your test, because basically the water is starting to saturate all the surrounding soil, and that is what's giving you your measurement of what is the soil. The fast draining stuff is just maybe, it's just wetting a dry soil. But once it gets past the, once it fully drains is what's going to give us our information about what kind of rate it is. It's going to be considered fast if it drains fully in less than 30 minutes. And typically this is a sandy soil. Again, this is a very imprecise test, not as precise as the other one, but it's a good cross-reference. So with these kind of faster draining soils, you're going to know, okay, this is rapid infiltration. So water moves through quickly. And that also means the rooting will also be pretty deep for these kind of plants, right? The roots can actually get through that very quickly. Medium draining would be something that drains in 30 minutes to an hour. Typically, this is a loamier soil. Again, that little, I don't want you to think, oh, medium, so it's silty. That doesn't mean it's silty. A lot of times it's a mix of, sand, silt, and clay, and it's kind of on the loamier end. So something in the medium range, that can be great, because it's a nice medium draining soil. You don't have to worry about slow or fast draining soils. But something to consider would be, it's probably loamy, but not necessarily, is something I wanted to make clear, which I didn't feel like I did. But also something to think about is this soil newly excavated? Is it loamy, or is it just like we newly dug it up and now there's these temporary air pockets that will settle out over time? So that's something to consider if you get a medium reading for your infiltration. But either way, you can plant these deep-rooted species, and you don't want to compact it. Kind of the slower the draining soil, the more you want to be wary of compacting it. And lastly would be the results of more than an hour for this hole to completely drain. And that would probably indicate some kind of clay soil, and that would be considered slow draining. And in these situations, you want to definitely go for the plants that are better suited for clay or heavy soils. And also you might want to, that would be something considering again for the irrigation, like how long I'm irrigating, and also potentially routing any surface drainage or water gutters. Like if you have gutters that lead to your backyard or your front yard or wherever your plants are, maybe routing it away from these slow draining clay soils, because you don't want to be having extended periods of saturated soil because it doesn't drain very well. I see I have quite a few questions. In a garden, do you want test infiltration in a dry area or wet? In this exercise, Margaret, we're just doing just whatever soil you have access to, and these results will work for either. So, and that's, you'll see sometimes different time. If you go online, it'll be like, it has to be more than 3 hours for a clay soil. And that will determine, we're just not making it very specific in this class. But essentially this should work for either a wet or dry situation. If it is a sandy, if it's wet or dry, it will drain in less than 30 minutes. And so that shouldn't matter is the answer. I have a 1 gallon pot. Can I do the test with that? Jerry, you can use the size of the pot to dig the hole, but you have to do it in soil, obviously. So I think that answers your question. Is there a test like this for potted plants? Oh, that's a good question, Milton. I think you could actually do the soil test by field, though the soil that comes in bagged things like from Home Depot or anything, a lot of times has peat moss and things like that. So it's not a real true soil and doesn't really have mineral components. So that would be interesting. But I do think what you could do is maybe something like taking just the straight soil that you get from the bag and pouring it over the 1 gallon pot you have, maybe like a 1 gallon pot, fill it with your bag soil and pour it, drench it over and see how long it takes to get there. But typically, I don't know why you would really need to do it with potted soils, because they are mixed to be well draining. So it's not really, I wouldn't think it's really important, but it's kind of a cool idea. I would like to add, try to always install your plant material and work through your soil when it's dry. Working with wet soil can interrupt the pore space in your soil. Of course, we are going to get into that. You definitely, ideally don't want to be tilling your soil or doing any kind of cultivation, like busting it up and stuff when it's wet. We have a slide about that actually a little bit later. So that is a good point to the question earlier. Do you want to do it dry or wet? Oh my gosh. I have this crazy mouse. Okay, let's see. Can I move this forward? Oh, yes, okay. So implications for maintenance. So this is kind of beating the dead horse a little bit, guys, but just making sure that this is clear that the soil texture relates to and impacts the infiltration. And you can see we go back to those pie charts here, and the mineral matter is still the same for a sandy and a clay soil. Like it still only makes up about 45% of the total soil, but you can see the water and air is different. So the pore space is occupied by more air in a sandy soil because of there's more air space between the particles, and the clay soil has less air space because these are smaller particles. And so actually more water takes up the space. So that's kind of how this breaks down for sandy and clay soils. So the larger airspace means faster infiltration, and the over here on the right, the smaller airspace means slower infiltration. And then this interesting example on the right here would be like compacted soil. So compacted soils is actually the soil structure, as was mentioned here in the chat by Thomas, the soil structure is so destroyed that you've actually kind of compressed more mineral matter in the same amount of space. So it's so compacted that it actually it acts hydrophobic, and you can see why, because there's so little air space, because literally it's been smashed together so much that there's not enough space for the water to move through, because there really isn't very much space between whatever mineral matter particles you have. Compacted soil is typically, I mean, it's just soil that is, the soil structure has been destroyed, and soil structure is kind of like the arrangement of different soil particles into different aggregates. And they are in different various sizes and shapes. And a nice kind of crumbly soil is what you're going for, or that's more natural, I suppose. But compacted would be like, it's been so destroyed, there's no identifiable like soil aggregate. It's all just kind of like dust, you know, it's more like dirt instead of soil. Are lawns compacted soil? That not necessarily, not necessarily. Definitely that you'd have to test the soil and check out the soil. So I didn't want to see if I wanted, so yeah, so in this situation, again, soil structure is so destroyed that it's actually kind of creates a hydrophobic situation where the water really can't move through it. So you would have poor infiltration in a compacted soil, even if it were sandy. So it's harder to compact a sandy soil, but it is possible with enough machinery and traffic and things like that. Oh, and then that highlights what Thomas mentioned, which is you really don't want to cultivate or work your soil when it's wet, particularly clay soils, because it will destroy the soil structure. And that leads to compaction, and that leads to decreased infiltration. So you don't want to create an issue if you don't have to. Okay, there's some kind of I guess vocabulary that people use, which is water holding capacity. I believe the woman in the video mentioned this. So also it's called field capacity, and this is just the amount of water the soil can just hold, like it's capable of holding. And clay soils typically have a higher water holding capacity, which kind of makes sense. What we were talking about, the smaller particles, they can actually just hold on to it better. And sandy soils don't really hold on to water. It drains very quickly. So they have a lower water holding capacity. And again, this is important for knowing where you, like what plants to pick for what soils, and also irrigation stuff, knowing how long to water and for how long to water and spacing of emitters, things like that. It's helpful to know the water holding capacity of your soil. Let's see, oops. Nutrient holding capacity, another kind of little vocab word. This is basically the soil's ability to hold nutrients. The large surface area of these tiny clay particles, so even though the clay particles are the smallest, they are rectangular, so they actually have better or more surface area for nutrients to kind of stick onto. And that actually allows clay soils to hold more nutrients than other soils. And they actually can even hold very tightly and not release them the same way with water, where they don't really, they absorb it and kind of hold on to it. Also, I mean, soils, again, is like, you could do a PhD on this. Also, clay particles are negatively charged. So that's another reason they can hold on to nutrients, especially all of our positively charged nutrients. But that's not for this class, but that's also a component for why they can hold on to it, not just their larger surface area. California native plants, though, they can thrive in clay. As we've talked about, there are many types for clay, and they are adapted to whatever nutrient content that soil has. And generally speaking, the clays and the sands in native soils are going to be low nutrient. Even though the clay has the ability to hold on to nutrients, it doesn't mean there's a lot existing in the native habitats. And they are adapted to these lower fertility or lower nitrogen soils. And that's actually why I would be very careful about over fertilizing with a clay soil, because they can hold on to so many nutrients. And generally speaking, you don't need to be adding any kind of amendments or fertilizers, especially synthetic ones, with your native plants. They don't need these higher nutrient levels, because like we said, they're adapted to low nutrient levels naturally in their soil. So we're not really trying to add any kind of fertilizer. And I'm just kind of warning you that with clay, it's even particularly a bad idea. Let's see, I'm going to go to the next. Oh yeah, so just a summary. Well, I guess, yeah, also you might see a result from fertilizing with synthetics. Like you might see a temporary increase of growth, like it won't immediately kill the plant. But a lot of times what happens is it actually shortens their life over the long term. So you actually get a shorter lived plant. So you might be like, oh, I've seen fertilizer, it works every time with my natives, which it will. It definitely will pump up their growth, but it's at a cost is the point, and it's not sustainable over the long haul. This summary of the soil qualities, this is everything we've kind of talked about. You can see on the sandy soil side, infiltration rate should be rapid, and because of those bigger pore space, the water holding capacity will be low because of that large pore space. They can't hold on to water. And same for the nutrients, because the nutrients kind of exist in the water. They dissolve in the moisture. So if there's big pores and the water moves quickly, there's nowhere for the nutrients to hang on to or stay. And that also means it has good aeration. Obviously it has big pore space, so a lot of good aeration. And then on the opposite end would be kind of clay, which there's a slower infiltration rate because of the tighter space between particles, higher water holding capacity, kind of holds onto the water and nutrients more, so hence the higher nutrient capacity. And then the aeration can be moderate to poor. So not all clay soil has to have poor aeration. A clay soil with good soil structure, like we were talking about, like good amount of aggregates, can actually have a moderate aerated soil. So it doesn't have to be a bad thing. Or maybe a very, very clay soil would just have very poor aeration. And then loamy soils, you can see, is just moderate down the way. I'm almost to, oh yeah, we can take a break. And well, I guess, but before we take a break, let's just see if there's any questions. Where's the best place to collect the soil, at the top or gathering it when the soil changes? Oh, for your soil test, I believe you're talking about, Milton. You just wanna, so when you dig your hole about 12 inches down, or 8 to 12 inches down, when you do the sorry, the infiltration test, grab a sample from around there. You want to usually get it between 4 to 8 inches. That's where a lot of the activity, root activity happens, within 12 inches. You don't want to grab from the very top, like, the first inch or two, but, below 4 inches, between 4 and 12 inches, grab some soil from that part for doing the soil test by feel. And is it good to add well-composted material for natives? Jason, we are going to talk about that. There's a case to be made against it and a case to be made for it, but we'll talk about that in some later slides. We're going to do a break. Oh, I'm a little bit behind schedule. So let's just meet back at, I'm going to try and stay on schedule. So, well, let's just do I guess we could do 6:19. Sorry, guys, it's annoying. But let's meet back here at 6:19. And we will continue with the lecture. And you guys can, Jerry, are you still here? Yes. So loamy soils is not the ideal soil. I was trying to make the case that they're a nice Goldilocks situation for agricultural and vegetable gardens. But for native plants, there's plenty of plants that can handle these slow draining soils or poor aeration or fast draining soils. So it's not ideal soil for natives. It is an ideal soil for like a vegetable garden, but that isn't what this class is about. So it's not ideal just because it's moderate all the way down. That's just the qualities of it, but it's not necessarily ideal. Yeah. Oh, I have to do a little bit of roll. Lola, it says, how do you add worm castings or compost? Is this more for vegetable beds? Yes, Lola, if you're still here, in a nutshell, it kind of is. There is a case.
Yes, I am.
Okay, yeah. It's more, we're going to get into it a little bit in the next couple slides, but definitely worm castings and composts are more for veggie stuff because they're for nutrients, right? And the native plants typically don't need much of it, but there is a case to be made. We'll get to that.
Okay, and then just based on your experience, do clients typically like to have a section of their gardens where they have like a raised bed or a vegetable bed? Because I'm assuming like since they like native plants that they
I see that
also
a
like
lot.
to.
Yes, for
Okay.
sure. Definitely if you offer that, I mean, I've worked, I don't do this, I kind of do both also because I come from the vegetable world, so I offer both. But I have friends who just strictly stick with natives. And some people are like, no, I don't want to have to deal with the water needs of a vegetable garden and actually just want pollinators and, you know, just to provide habitat, especially I think with the like the parkways in the front yard, maybe where you might not be going outside there as much, right? You know, that there's that permaculture concept of like kind of the zones closest to your house is where you should kind of keep your vegetable gardens because there's a lot more maintenance. So I think in the lower maintenance zone, I think natives make a lot of sense. And, you know, just forget about vegetables, you know, because they do need a little more tending. And so I try to keep those as most as I can closer to areas where people are like trafficking or frequenting, so they actually take care of them. Because I don't know, in my experience, vegetable gardens look worse when they're untended than other gardens. Like when they go neglected, they look terrible. Whereas I think it's a native garden, when it gets neglected, it just looks like a little bit, you know, curlier or wilder. But and a vegetable garden can look pretty trashy when it's not tended. So what's safe way to stop caterpillars from killing your vegetables? Jerry, let's talk about that in the pest management class. Yes, Hobbs compost is also with worm tea or some liquid fertilizers. That's some good points. Morning and evening shakedowns, I like that. Okay, I'm gonna start with the lecture. I'm a little bit behind. So I just love talking about soil and I kind of beat the dead horse a little bit too much, I think. Sorry, guys. So let's go through a little bit of soil-based problems that you can see with problems with the soil, which would be slow infiltration, which we kind of talked about. It's not necessarily like a death sentence to have slow infiltration. It's really just about being cognizant of it. And a lot of your gardens that you've maintained or you are maintaining, maybe you inherit, they may have clay soil, but they were not planted with that in mind. So the wrong plant for the wrong place can be kind of disaster, can really spell disaster and death for plants. So it's really about just replacing those plants with those that are adapted to clay soil. And this is where I would really recommend you guys to go to your handout for this week in your in this class. It's the native plants for heavy soils. It's like over 50 plants that are really great for heavy soils, which is, you know, typically the clay soils. And so good for slow infiltration. And there's tons of options. So you don't have to feel like you have to like restrict your garden's beauty or options because of slow infiltration. Some additions I wanted to add that were not on this list or that are not on your handout, but are good for clay soils are a Butylon palmarii. So the Indian mallow, that one does pretty well in clay soils. Just to add to that list if you have it out or add it to your notes. Also there's Berberis nevinii, which is the Nevin's barberry, the San Diego sedge, Carex spissa, that's also good. A lot of the kind of grass or grass-like things do well in clay. Also the seaside daisy Wayne Roderick, the Erigeron glaucus Wayne Roderick, that's great, does well in clay soils. Also Tecate cypress, the Hesperocyperus forbaceae, and the Douglas iris. Douglas irises are native to kind of slow draining soils. So they do great. Iris douglasiana do great in the slower draining soils. Two other ones that are hits that people always use is white sage, Salvia alpiana, that does okay in clay soils. And so does hummingbird sage, the Salvia spathaceae. There's a lot more options. Those are just ones that I saw that weren't on the list or that weren't on your handout. But there, like I said, there's over 50 different ones. So there's plenty of options when you have a slow draining soil. So it doesn't have to be a problem. One thing that you should note is though these plants that are on this list or that I mentioned they work in clay soil, they still can be sensitive to overwatering. So it doesn't mean like, oh, it's okay with slow draining soil. So that means I could just water it to hell and, you know, it's fine with it. A lot of them like white sage, they're still going to be sensitive to overwatering. So that doesn't mean you just get to like, you know, all the rules are off. Okay, there also can be the issue of like another soil-based issue can just be pathogenic activity. So this slide also could be like a whole PhD. Excuse me, wrong pipe. So soil pathogens are just microorganisms that cause plant disease when a spore or cell or fungal kind of hyphae invades a plant by way of the soil. And really pathogens, they, this soil food web picture here on the right is that soil organic matter zone of, like, this is talking about that little sliver of the pie. And really pathogens exist naturally in the soil. There's no, we don't need to sterilize it or like remove them completely. They do exist naturally in the ecosystem. It's basically like a soil ecosystem that the food web is happening in the soil. So we want to actually cultivate it. It's really when one of these pathogens gets out of control that it becomes a problem, not that it exists at all. So really this living portion of the soil is super diverse. You can see that this organic matter is like the waste residue or just the things, the exudates and metabolites that come off of the roots, and they feed bacteria and fungi, and then that feeds nematodes, and other nematodes predate on them, and protozoa, and goes on and on up the trophic levels. And really this is just the natural cycle of the soil ecosystem. And this is what we want to recreate. This is what we're trying to mimic. Because this is a nice, healthy, diverse community of microbial organisms, right? So we want this nice, diverse community because really they're just cycling nutrients by eating and shitting each other out over time. And we want to recreate this so so a pathogen doesn't get out of control. And if you have a nice, diverse community, you have beneficial microbes. When you have a diverse community, you have also present beneficial microbes that can take care of any of those pathogens before they get out of control. So really trying to recreate this like healthy, diverse, intact soil food web is key for keeping any soil pathogens at bay. It's not about trying to like spray them away or get rid of them or drench your soil with some kind of like bleach or something like that. It doesn't work like that. Really, there's like a very complex, obviously, relationship amongst a wide range of community members here. And that's what we're trying to get going. So what we want to do to avoid pathogens is really just not create the conditions where they thrive. So something like Phytophthora, which is like a fungal pathogen, it causes root rot or vascular wilt, and it kind of like just makes your plant die sort of seemingly overnight. And the way it works is it actually produces these rapid swimming little spores that enter through the root, and there's no wound necessary. It doesn't need a wound in the root to enter it. It just enters through the root and actually can kill the plant. And it only thrives in conditions where the soil is waterlogged, even for as little as 4 to 8 hours. And like, so very short amount of time, if the water is just like waterlogged, like sitting there. I literally unintentionally did this on a plant where I had a pot, it's a plastic bag pot, and they usually come with holes, and I didn't realize that one didn't have the holes. And I remember I watered the plant real good, and then a couple hours later, several hours later, I came back and saw that the water was still sitting on top, which is weird for a potted plant. And I realized there were no holes below. And then a week or two passed, and the plant is already like yellowing and dying. And I guarantee you that was probably a Phytophthora. And it was just Phytophoras in the soil, and it wouldn't have been a problem had I not let it sit in sopping water for many hours. So that's what we're doing with pathogens, is trying to avoid creating conditions where they thrive. And also one thing is not, so like this little note about tilling breaking up the soil food web, that is also a hinder or like a problem, because what you do when you break up this community in the soil food web, you actually destroy all the beneficials, you destroy all the connections, you destroy the whole community. And that means that if a pathogen gets in there, there's no predator necessarily, so it can maybe take off. So tilling your soil actually destroys these connections, like the mycorrhizal fungi and all of these, essentially this is their home. So it's like if you came in with a hurricane through your community, it would destroy your home. So it like kind of throws off the whole soil food web. So I think that's pretty clear. We want this nice intact community. Also, when people refer to feeding the soil, it's really you're feeding this soil food web. You're feeding all these community members, and then they break down the nutrients in a form where the plants can actually take it up, and that's how we feed the plants. It's really having a diverse community that feeds these plants. We're not really feeding it with the compost itself. These community members are. We're just providing food for them. So this is just kind of a key component of the pathogen kind of concept. It's a lot like E. coli in your stomach, you know, your gut biome. You have E. coli naturally in your stomach. It's just when it gets out of control, when you're maybe like eating a lot of fried food and garbage, and then you eat something that's not so healthy, that's when the balance is tipped, and that's when you have a problem. It's the same with your soil. Okay, another potential soil-based issue could be compaction. We kind of talked about that a little bit. So compaction is when the pore space is very small, or the pore space between the mineral particles is much smaller because of the pore structure. Usually it's destroyed by machinery or over-tilling it or traffic. You know, maybe a car drives over this area all the time. There's a lot of things that can cause compaction. But compacted soils, some compacted soils are clay, but not all of them. You can compact any soil, really. Clays are just more risky, I guess, are more apt to be compacted. It's easier to compact them, especially when they're wet. And sometimes we use this term compacted when the soil is actually hydrophobic. So it could be, it's so dry, like a yard that hasn't been watered in a long time, and it doesn't absorb water. Water just rolls right off of it. And it's become hydrophobic so much, so hydrophobic and so dry that it doesn't absorb water easily. That might not be a compacted soil. It might just be hydrophobic. You can also have compacted and hydrophobic soil. So like a soil that's compacted and also hasn't been watered in a really long time. So you can have all the options. The only way to really decompact a soil or to solve either of these hydrophobic problems or decompaction is through slowly wetting it, you know, over in regular kind of short doses, especially if it's hydrophobic, and adding native plants and organic matter. So that's because the roots themselves will do it. If you're just watering it and not adding plants, it's not going to do anything for compaction. But, or, I mean, maybe it'll make it a little less hydrophobic, but the plant roots themselves are what actually breaks up the soil. And you can see in this, like, this figure here on the right, these are not native bunch grasses, but we do have native bunch grasses. I think this one on the right is actually native to the East Coast, but they all have similar root systems. And you can see something like turf grass, like a lawn, has very short roots. They're only in the, you know, couple inches down, whereas our bunch grasses can go down several feet deep. And they're these dense, hairy mats. So these actually break up the soil. And all of this is going to be feeding that soil food web. It's going to feed organisms with all its exudates and all the little nutrients that it kind of sheds off and absorbs too. So the bunch grasses are really great for breaking up compacted soil, and plants in general, plant roots. A lot of our, just having more plant life is going to add more life to the soil, which then decompacts it. Mycos or mycorrhizae, I've definitely used those for at installation, you know, especially with a new yard, maybe that doesn't have a soil food web yet or something. I've used them. I have seen results, not like crazy striking difference. Sometimes I would maybe use it for a plant that is very sensitive to transplant. Maybe that would make sense, or yeah, like something I really want to ensure that it gets established. Those can be helpful, but it is a cost prohibitive thing. Sometimes they're very expensive, these products, and it depends, you know what I mean? So I definitely have used it, and I think they do help, but sometimes the relationships with the mycorrhizal, I've actually seen it used more with vegetables, and native plants tend to have these very specific relationships with the specific mycorrhizal groups. So I tend to think that maybe the science hasn't quite caught up to actually provide the right ones for native plants. Whereas with domesticated plants that we've had years of working with, I see the mycos work a little bit better with that. Pocket gophers will decompact too, right? I mean, technically animals are decompacting, earthworms are, you know, it's the trade-off of the pocket gopher maybe actually eating some of the things you want to. Managing soil. Okay, let's see my time. Oh, I hate being behind schedule, but I am. So I think we're okay though. Let's see, are bunch grass is particularly helpful for decompacting soil? Yes, Margaret, that is exactly the point of that last slide. Bunch grasses are very helpful for decompacting soil. David asks, my takeaway from today's soils class is that plants need to be selected for the soil type. Exactly. Don't need to import and do not till soils to get better aeration or reduce compaction. Therefore, plant natives and add organic matter. Does the organic matter get tilled in a few inches? Not typically, David. We're going to get into that. You just segued into mulch, basically, which is the managing soils part of this lecture. And mulch is basically just any kind of top dressing that you put on top of the soil, on top of bare soil. There are several types. It is different from compost, though people use that interchangeably. Many people say mulch and mean compost, or say compost and mean mulch. But technically they are different, and mulch is just something you put on top of the bare soil. Compost is usually already decomposed. It's already like kind of at that, all the little particles have already broken down. What was I going to say about that? I just lost my thought. Oh, and mulch has not started the decomposition process. And you usually see that it has like little wood bits and pieces that you can kind of identify, whereas compost, it looks a lot more like kind of like a soil. You will hear, even by people that sell mulch and compost, you know, these providers, a lot of times they'll say composted mulch. I kind of don't like this term. It's not helpful, but usually what that means is it's been treated by like some high heat process, maybe some kind of composted process. But what they're trying to indicate to you is that they've treated it at a high heat and they've killed most of the weed seeds, which is helpful to know. But know that it's not truly fully composted if you can see wood chips and all those things in it. That's just kind of a misnomer in the I guess, industry. But one thing to note is that LADWP's requirement for the turf replacement program requires 3 inches of organic mulch, which is usually the woody shredded mulch. So essentially, I'll get into inorganic and organic mulches, but why we use mulch would be something like conserve moisture. Obviously, it covers the soil, so it kind of moderates the temperature and doesn't allow so much water to evaporate with that nice kind of covering. Reduces weed growth, because if you have something on top, you can be smothering the weeds, or even just blocking the light so they can't photosynthesize. It does alter the chemical and biological composition of the soil to some degree. That's that soil food web thing we were talking about. It's on a very slow time scale. It's not going to be overnight. But yes, if you are feeding the soil biology, if you're improving it, yeah, you are going to change it to some degree, you know, at least in those top few inches. That's where most of the kind of soil biology activity happens. The next points are all kind of aesthetic things, like indicating pathways, obviously, or focus points, or just kind of identifying, you know, maybe an outdoor room, like this area is for play and this area is for plants, you know, or even just giving the garden just a more finished appearance, you know, not having this exposed dirt. Sometimes it's just nicer for people to look at. That all being said, mulching trees, okay, I feel like this just doesn't have its own slide, but it can recreate kind of aspects of a forest soil environment, even in like a sun-baked landscape. So if you have a tree that maybe like a scrub oak that wants to be more of in an oak woodland area and is accustomed, the plant community is accustomed to a bit more leaf litter, then mulch can provide that. You're basically trying to mimic and recreate their plant community conditions. So in a desert community, you're not going to see as much plant litter or leaf litter. So maybe you don't need to mimic that as much, but it can really help with that. Different plant communities have different types of leaf litter. So that's another reason why you want to think about, where does this plant come from? Does it really need this kind of wooded mulch, or does it need more of like a decomposed granite type of mulch? You just basically want to create the conditions of that plant's community, you know, as best as you can. It doesn't have, you know, it's not going to lead to direct death if you don't, but it's just the ideal conditions, right? And then just like kind of a PSA, I guess, would be if you have a oak, leaving that natural oak leaf litter mulch is so important. It's like really important to the oak's health. and don't remove it, as best as you can, leave it in place. It's so important for obviously all these reasons, like conserving moisture. And it also is a really important part of the tree's nutrient cycling. And it also is kind of like the tree's immune system, because so much of it moderates that soil food web. So when you remove it, you actually kind of put the tree at risk, at higher risk for developing disease or having problems. Types of mulch. Okay, so you have basically inorganic and organic mulches. I have blind getting in my face. You have organic mulches, which are formerly alive products that will break down within our lifetime into some kind of humus, you know what I mean? And the inorganics are not going to break down in our lifetime. Rock is not going to break down into soil in our lifetime. And neither are the kind of plastic products. I'm going to go through each of these more in detail. I guess I should check out your guys' questions. I just got all ahead of myself. California native bunch grasses, Connie, I would check out. Theodore Payne has a list of good bunch grasses. Easy weeding. My yard gets a lot of pine tree needles and other pine tree droppings. Ooh, you're like Margaret, you're just like segueing into the next slides. Okay, looks like you guys are answering it. Thank you guys for answering the chat questions. Love this teamwork. Okay, so tree bark or shredded wood material, that's a really common mulch. And I think most people, when they think of mulch, when you say mulch, they're typically thinking of this kind of shredded wooded mulch. The shredded wooded mulch is preferable to like tree bark, because the tree bark is kind of that thick, bigger pieces and they take longer to break down. And the shredded mulch is a bunch of different size pieces that kind of weave together, stay in place. And actually, because of all the different size pieces, break down at differing rates, which is perfect and more like emulating what it's like in the wild, right? It's not all bark as a native mulch. It's usually a bunch of different plant litter and plant pieces that are different sizes. So they break down at different times, and the plant gets to benefit from like a slow dosing of nutrients. Let's see if there's anything else. Tree bark or any equivalent shredded. Oh, right. Definitely LADWP requires this. And because they are partners on this program, we have to put that in the slide to make sure to remind you guys that organic mulch is the only one that counts for the turf replacement program. One thing, there are free chip drop type services or tree trimmers that drop the tree shredding bits down at your driveway. These are great as a free resource, just as a heads up. Because they're so fresh and green, they have a lot of nitrogen and they're very hot, we would say. And they are actually hot too. If you stand in front of it, it like is steaming and feels hot to the touch. So in that case, I wouldn't apply it directly, or you can apply it directly to the soil, but I wouldn't put it directly on plants. So maybe apply it, let it dry out a bit, and then plant. Because that's so hot, it can create kind of like cooking situation for your plants, but also the soil itself is going to try to break that down. And it's so high in nitrogen that it actually steals carbon from the soil temporarily to break it down. So definitely just, it's a great free resource. I wouldn't say don't use it. I would just say give the time between a planting and between applying any of that fresh stuff. But the wooded material that's dry and old is fine to apply day of and plant into directly. Yeah, the free chip drop. I think that there's a service called Chip Drop that you actually just, it's an app, and then you can sign up for, you just tell them your address and where. And the only thing is they will just drop off whatever they have. So you have no choice on how big it is. And it can be a lot of material or what kind of material that they're dropping off. I think you can ask them not to put in big like stumps. That's the only thing you can ask for though. And so you don't have, it's not, but it is free. So it's great. And they come whenever the hell they want. So just be prepared and maybe tell your neighbors in case it's a big load so that you guys can all share it. And then the free ones, that's the only ones I can think of, unless you can contact a tree trimmer directly, like, you know what I mean? Get in contact with them. Otherwise there is free mulch through Griffith Park. There's lots of, you have to go for it though. Obviously you have to go get it. Yes, Thomas, the free mulch a lot of times means free weed seed and palm seeds. So that's absolutely true. It's not the highest quality mulch, But if you are, cost prohibits you from having anything, I would suggest mulch over nothing, or even a low quality mulch over nothing, especially in certain situations. Okay, decomposed granite. This is really great. This also can be a mulch. It's an inorganic mulch, obviously not going to break down to humus in our lifetime. Great for our desert natives. You know what I mean? This is because of that higher drainage need, faster draining, faster infiltrating soil preference of our desert natives. Usually 2 to 3 inches. It actually can help retain the moisture because it is on top of the soil. Not as much as like a wood mulch, but with our desert plants, they don't need as much help. And also really great for that firewise 0 to 5 foot zone around your house. Really great to have DG because yeah, it's not flammable. And in the rebate programs, I'm pretty sure this counts as hardscape pretty much always. So it won't count as mulch if you're applying for the rebate program. Rocks and gravel, a lot like DG, but bigger, much bigger. And rocks and gravel can be a mulch for sure. You know, you lay it on top of the soil. They do get expensive because they are, you know, you're buying it by weight. So rocks and boulders get very pricey fast, but they're great and they look lovely. They're not allowed by the rebate program, must say that. Also really good with the desert installations. A lot of times those big boulders I mentioned, the nurse rock, putting something next to a new planting, they kind of help. They can shade an afternoon shade. They can do like afternoon shade. You can place it appropriately and also just kind of helps with moisture. So definitely works. This little note here is more about when you're putting down the rock. You want to start with your big boulders, place those first, you know, and then do your cobbles, you know, the next size down, and then work down and then fill in with the smaller. And it kind of makes it more natural, like more looks like a more natural look to it when you're laying the gravel down. It doesn't necessarily change it in terms of function. It's just for the look. Leaf litter. Rocks do not necessarily compact soil if they're just sitting there. You know, if you're driving over them or passing something heavy over it, you know, machinery, or walking over them a lot, then yes, it will compact the soil. But if it's just sitting on top of the soil, it actually can be protecting it. It's more about the compaction usually comes from, am I saying this? I'm trying to think if this is true. Just came to me. But compaction usually comes from like movement and traffic that moves, not just like a heavy weight on top of it, sitting on top of it over time. But I'm sure there's an exception to that because it just came up to me at the top of my head. Oh, okay, leaf litter. Includes, okay, so leaf litter can include pine needles, oak leaves. Someone I believe mentioned in the chat, pine needles can be more acidic. And so yes, that can create more acidic conditions. And even, what's it called? Eucalyptus, it's phytotoxic. So it actually emits kind of chemicals from its leaves and stuff. And when it it actually emits chemicals to suppress the growth of other plants. But what I typically see is, unless you have like a lot of it, it's not going to change the composition of your soil. And I don't see it doing a lot of damage. I have had people tell me examples of like, I'm surrounded on all sides by eucalyptus and nothing grows in my yard, which could be the case. But I wouldn't worry about a little bit of pine needle mixed into your mulch or even eucalyptus. I have definitely done it, and the plants it's really about proportion, like how much is in there. With leaf litter, you want to try to keep it in place, like I was saying with the oaks. Even with your little guys, this salvia on the right, a lot of leaf litter, leaving it in place is going to contribute again to that soil biology, the soil food web, and add carbon to the soil. All of that carbon is food for the soil food web. So it's really the natural free mulch that comes off your plants. So keeping it in place is the best case scenario. And like any mulch, you want to be careful not to pile it up too high. You know, you don't want like 8 inches because then it's hard for water to infiltrate, but it's hard for it to get that high naturally. And then also just keeping leaf mulch away from the crown of the neck, which is like the stem of the plant. I'm pointing at my neck because I'm thinking if I was a plant, it's like the neck of the plant. You don't want it to be, in it like covered with mulch, especially an organic mulch, because it can kind of create rot conditions. Oh my God, I totally agree, Jason. Yes. Mulch is great for all of our little, like all of the wildlife, like birds, they love digging through that kind of stuff. But again, just knowing that we want to keep the natural leaf drop, because it's not just habitat, or not just, you know, kicking around for the birds, but it's also habitat for a lot of our pollinators, and our what's it called? Native bees actually use little plant parts and stuff to burrow in or use it for their nests. So it's very helpful to leave it in place, because again, we're mimicking this natural cycle. We want to do that as much as possible. We have recycling of yard waste, like grasses and things like this. Not ideal. Again, a lot of weed seeds. You really want to be careful with hay. It breaks down really quickly, but it has a lot of weed seeds in it. And so it's not the best case scenario for a mulch, because it does break down so quickly. And straw you could use, but again, kind of breaks down. Straw would have less weed seeds in it, shouldn't have any. But yeah, I would probably compost this before I ever applied it directly to the garden. It's I guess if it's the only option you have, but you might be creating a weed situation first. Shredded post-consumer products like newspapers, cardboard definitely can be used as a mulch. I wouldn't put it just directly exposed, because it'll probably just blow away, but they work really well in sheet mulching situations. So you actually apply it directly to the soil, or cardboard, and then you put like the wooded mulch on top, and then they all break down over time, and it works great for that. And it's obviously free and easy to come by, so it's a great resource, adds carbon to the soil. Lastly, I think, petrochemical products. This is basically like kind of rubber bark mulches or geotextiles. We don't want to use these because they don't break down. The only way they break down is into microplastics, and who wants more of that? And more importantly, they are not adding to the soil biology. They're not feeding any of that soil life. So it's not helpful for the soil food web, and thus your plants and your landscape. Okay, how much mulch? We're talking, usually we say about 2 to 3 inches. With the LADWP, it has to be 3 inches. So that's why it's 3 here. But again, like I mentioned earlier, you don't want to pile too much mulch around the trunk or stems of plants, because it can create these like rotting conditions. They don't, they're not, you want to keep a little space between, a couple inches from the plant itself. Wait, there was some more I wanted to say about this. Oh, well, like I said, ideally, you apply mulch at installation, and that's because usually you don't have mulch sitting, native mulch there. So you have to put something down to protect the soil and kind of initiate that process of improving the soil or like creating the conditions for the soil to be more like a native soil. So you initially put the mulch down, but you shouldn't be having to apply every year. Typically the plants will start to shed their own leaf litter, and that is enough replenishment for the mulch it doesn't have to stay 3 inches its whole life, you know what I mean? But usually once it's established, it should be fine, and the plant is shading itself enough, and it doesn't need all that thickness of the mulch to help it along. Really, ideally, we're just trying to promote this natural cycling of nutrients, like I was saying. And as was mentioned in the chat, mulch is great for providing habitat for beneficial insects, birds, and lots of other species. So it also helps with the kind of immune system and pest management of your native plants. You don't want to use plastic, what is that stuff called? Or like weed cloth, or that plastic stuff you put under the rocks. You want to avoid that. These do not encourage and they don't encourage that natural cycling. They actually prevent it, especially the plastic ones, because you can think like there's no respiration happening. And the weed cloth are the same. They actually kind of suffocate it, and they actually can create more compaction, speaking of. But the idea is we want to create a healthy soil food web, and these weed cloths or the plastic lining under stuff, it doesn't help do that. So avoid it as best as possible. And the mulch really is kind of your fertilization program with native plants. That's all you need. The mulch is breaking down, and there is nitrogen inherent in these organic mulches, at least. And that is going to break down slowly and provide the needed nutrients for native plants. It's not much, but that's all they need. So they really don't need high levels. Amendments, let me see where I'm at the time. Oh gosh, guys, I'm getting there. Okay, so amendments, like I just said, don't really need to add additional fertility. It's a lot of times you're adding like extra fertility with synthetic fertilizers, and you actually encourage weeds. You open up a niche, and there's like all this. It's like you made a buffet, and the only ones that can take advantage of it are the weeds. So it can be detrimental. And like I said earlier, it can give you quick growth, but it's not sustainable. It can shorten the life of a plant over time. And we were talking about this, is there a case to be made for compost? Typically, like this says no. I would say no compost too aggressively. So the way you compost for a vegetable garden is very different. It's harder to over compost in a vegetable garden. It's possible to add too much with a native. I might add it at installation in a highly impacted garden setting or like lawn or something that's just terrible. And even then I wouldn't just dump it in the hole. I would just do a top dressing, a light top dressing, and maybe put it, in the top couple inches or something. But that would be at most. One condition I would see that would make sense with composting would be native plants in containers. So in containers, they're in this altered situation that is not normal. And they're in a kind of a false, what is that called? Anyway, I'm trying to think of the word. I'm thinking alternative. Anyway, you guys know what I'm talking about. Anyway, they're in a kind of not a real situation. It's not a artificial. Thank you. I was like, what is that word? It starts with an A. Yeah, so they're in an artificial environment. So you can compost in that situation, or sorry, maybe use a compost tea or add a compost maybe once a year or something, depending on what kind of plant you have in there. I could see the case being made for adding composting or fertilizing. I don't even want to say that for containers, but I could see the case being made for it in an artificial environment like that. But again, ideally, I would use the lowest nutrient level, lowest nutrient kind of fertilizer, like a compost, or a very low dose of, if it were a synthetic one, very, very low one if you were to use it with natives in a container, because they really just don't need a lot. Changing your soil texture, we talked about this. Don't do that. Don't try it. Doing the whole tilling process of digging up and trying to, if you were to bring in a bunch of truckloads of sand because you want to make your clay sand, and actually you like pay to have that labor intensive process to mix it all, it's so costly, and you just really aren't going to achieve it. And in the process, you're going to destroy all of your soil structure. It's like such not a good idea, if I can't express it enough. And also, I mean, if you think about it, like sand, clay, and a little bit of organic matter with water just makes adobe bricks. So you potentially could be very dangerous to like just creating like a total mess. So just again, it's tempting to want to change your soil structure, but just keep what you have and really pick the right plant for the right place, the right soil. Okay, this is the last couple slides. I'm going to answer your guys' questions at the end since I'm a little bit running out of time. I kind of wanted to make you guys identify all these plants, but I'm going to do it so that I can get through this, the last slides. But if you guys see here, these all in front are, anyone want to like mention it? I mean, maybe you guys can shout it out quickly, what that purple pink one is in front. Anybody know what that is? Or any of them?
Are they penstemons?
Yes, it is very pixelated. I don't know what happened to the photos, but I'm not a computer person. So anyway, penstemon, that's Matalia poppies in the background, and the fried egg poppy, yes. And the hummingbird sage are these here, pixelated, but they're these kind of iconic large stalks. And then here, the last one I wanted to point out is this is looks like Erigeron glaucus. You can tell by the little daisy, and that's what they look like. They're very low growing. But what I wanted to point out is all of these plants are on the list for heavy plants for heavy soils. So just because you have a slow infiltrating soil or clay soil doesn't mean you have to sacrifice like the beauty of the garden. This is obviously, I mean, it's not that beautiful because of the damn pixelatedness, but I'm sure you guys can imagine it, which is a lot of these plants will do really well in clay. Again, they are sensitive to being overwatered, but they are fine in a slow infiltrating soil. Lastly, I'm just going to mention kind of a lot of the lectures have these kind of extras, which is if you're a landscape maintenance person and you're just looking for other activities you can charge for potentially, or other ways to kind of sell your services. Soil analysis is an option. Typically, I don't think this is fully necessary, especially in kind of the residential situation, but you know, it might be. I think you can perform these kind of like, there's a lot of different ways to do it. You could just do something like a simple settling test, or just to, you know, kind of show them what kind of soil type they have, what that means for the infiltration, and kind of explain that. You know, there's a lot of opportunities for education with homeowners. Or you can do actually send a soil sample out to a lab. Wallace Labs is a great option for Southern California. This makes more sense to me, sending soil to a lab for if someone wants to do edible gardens or edible stuff, or maybe they're having trouble getting stuff established, like they've had years and years of problems with stuff, then I would maybe send it to a lab, because it's like, okay, something's up here. But you could do all those kind of DIY things and just offer that as like a preliminary consultation. Maybe just get them in the door with all your knowledge. But yeah, soil analysis is an option for sure. Planned replacement program for mulch. Like I was saying, you shouldn't have to do this as the garden matures, but in a young garden, maybe it's having problems with runoff or something, and the mulches or getting wind whipped around, or who knows, or maybe there's just bare spots they never applied enough. You can offer the service, just be like, okay, I'm charging for the actual materials, the delivery of it, and you charge for the labor to spread it out. I think in one of the older classes, there was someone mentioned that someone just basically, this was like a majority of they would go around kind of offering this service to people who had not mulch gardens. So it can just be a regular income thing, and very easy work to spread mulch. I mean, I would even argue it's kind of fun, but maybe that's just me. Oh, and lastly, BMP stands for Best Management Practices for Soil Health. So I don't know why this is in here, because I really don't see this happening on a home scale, but this is testing the soil in multiple locations kind of before and after you have either installation, or before or after you've started implementing the best management practices. So like appropriate plants for, you know, the soil type, maybe keeping mulch in place, all these kind of good practices that we're talking about. And you can report, like kind of create reports for the client in writing that would be like kind of before and after to show the results of these best management practices. Like I said, I don't think the typical homeowner would be into this, and it seems like an extra cost. I have done stuff like this definitely on ranches, you know, big properties, and we would actually measure, we'd have several different employees do kind of like a semi-subjective kind of survey of the soil using different things. Like you can test microbial activity, compaction, everybody does a soil test, and then do that afterwards, you know, next season or something like that. And you can actually, I have done something like this and offered it as a service, but not in a home, like a residential kind of setting. So that is it for the lecture. I know I'm right at the end. Homework, I just want to make sure we get to, mentioned it. The infiltration rate, sorry, you're going to check the infiltration rate and the soil texture at a work site. If you don't have a work site to go to, just do access to some soil that you can do. And again, we talked about it. You have your flow chart for the soil texture by feel, which is like the ribbon test. Use that flow chart. But essentially it'll be, you know, dig a hole, the pot-sized hole. And once you get down to that bottom hole, get some water in there, try to do the ribbon test or the cast, you know, try to form the cast. Note what soil type you have from it, and then fill the hole with the water and make your measurements over time and determine what kind of infiltration rates and compare, you know, like, are these results, do they hold up? Do you have a sandy soil and fast draining, you know, or is there a discrepancy, and maybe why do you think so? And then it says bring photos to the class, but you can just email me those. Email me the photos of the empty and the full hole, and your results. Like, I want to know what soil type did you get from your soil by field test? And again, use the flow chart. And what results did you get from the drainage, the percolation test or the infiltration test? Okay, I know I'm running late, so if you guys got to run, you got to run.
Do you have a preferred time for the test?
Sorry, say that again.
Do you have a preferred time in the morning and at noon?
No preferred time. Like this class, I think is for more of a simple, we're not trying to do crazy soil science. So any time of day that you can is fine. Because the infiltration test too won't affect, though plants kind of absorb water more quickly in the hotter parts of the day, it's not going to affect the infiltration at any level like that. I guess if you guys want to shout out your questions, if you have any, and I'll just kind of go through the chat to answer anything I see.
Claire, I have a question.
Yes.
There's been some comments about different soil types and things, and then we're talking about mulches and ground covers and things like that. So I was thinking, is there like a preferred, for example, if you have sandy soil, is there a preferred kind of mulch or compost, and then like versus a clay soil? Like maybe if you would say, would there be a recommendation if I have clay soil to use this kind of mulch versus another type? You see what I'm saying?
Yeah. Sadly, I can't give you a direct answer, but typically if it's more about the plant palette you're using. So if you are, and I would typically, if I had sandier soil, pick more, higher, faster draining, maybe a desert natives type thing. If I have a very sandy soil. And in that case, I would be fine with picking a kind of more drought tolerant palette. And in that case, I would probably use more of a DG or something that we don't need, and again, it goes back to what plant community, what does the plant community look like? And then
I get it. It's what you're planting is the difference. But I guess like if you're trying to improve the overall quality of the soil, like maybe, but some plants would prefer DG. No, I get what you're saying. Yeah, you have to think about what you're planting.
And I think too, this because I struggled with this for like a kind of a ridiculous amount of time because I came from the vegetable world, and it's really put into you about wanting good soil, improving your soil health, that I think sometimes we kind of keep that, we have that mindset. And when you're thinking about improving your soil, you have to ask for what, and sometimes if it's just like usually the mulch should be enough, an organic mulch for a plant community that has that kind of mulch, maybe like a chaparral has quite a bit of leaf litter. So I would just recreate that. And again, if you have a very clay soil, I wouldn't think so much about the mulch, but about which plant I'm putting in there. And sometimes a lot of because that's the thing is you could have a clay soil that is still a chaparral environment, or you could have a clay soil that's very close to a riparian environment. And I would say the chaparral doesn't need tons of leaf litter, but a riparian one could handle quite a bit, or they both can have it. You know what I'm saying? So, but generally speaking, I'd say desert, sandier, more on the kind of decomposed granite. And then leaf litter is more for those perennial ones in the chaparral communities, oak woodlands, even riparian. I mean, almost everybody else kind of can handle the wooded mulch type thing. Sorry, it's always like a bad answer.
That's a good answer. Thank you. I appreciate that.
Is there a mulch you recommend on the hillside? I see gorilla hair used a lot, but fire, yes. This was actually a discussion when we were creating this curriculum. I believe LEDWP is very much against putting gorilla hair on the hillsides because of the fire aspect. And then a lot of folks are like, well, actually gorilla hair weaves together really well and it stays put really well on the hillside. So I think if I had to give you my kind of like within this LEDWP thing, I would say do not put it on the hillside, but I have seen it put on there for sure. I actually sometimes think the wooden mulches work on hillsides, especially if they're the shredded mulch types, because you have all the different size pieces. So they actually kind of lay all right on there. You can, I'm trying to think, I mean, yeah, gorilla hair can be a good one. But again, like I said, the flammability, but I would say sometimes if it's like if you're creating a desert community on your hillside, you could do, I would say the shredded wood mulch, actually. Yeah. I think it's helpful to have preferred mulch for each soil type. Yeah, it's hard to pick exactly that.
That was me. You already answered.
Yes. Yeah, okay. TPF actually, I don't know if they have a handout for hillsides particularly, but hillsides you can think of as being well draining, because I mean, just by gravity alone, they are draining water off of them. So even if it's not percolating directly, even if it's a clay soil, it's actually shedding off of them because of that incline. So you might think of it in terms of a higher draining soil. I don't know if they have a handout for hillsides. I don't think they do, but you could check it out. They have one for everything, so I could be wrong. Oh, Milton says that CalScape has that. That's great. CalScape apparently has a section for hillsides. Oh, basic fertilizer you recommend? I don't have a basic one because I wouldn't typically use one. Again, like I said, I'd be in the 0 range or the 0.1 range. Usually compost teas are in that range. So that's what I would use if I were fertilizing with like a fertilizer or something. And if I was using a like synthetic one, I'd get the lowest one I could possibly get. And then I would even dilute it some more. Oops, just ripped my headphones off. So I would dilute it to be less concentrated if I were to use a synthetic one. Sorry, yeah, guys, if you have to go, I totally understand. I'm just gonna continue answering questions if you guys wanna shout them out, but please feel free to go. We'll have class on Friday. It'll be about irrigation.